Hi, this is Davide Seni from s.t.a. and I'm the product owner of Tremuri. Today we are talking about seismic assessment and retrofitting for masonry structures. First of all, I would like to introduce you our company. s.t.a. was founded in 1983 by Adriano Castagnone, and the company provides civil engineering services and consulting. Thanks to the continuous development and work and collaboration with the university and professionals worldwide, it's always able to offer advanced and constant updates to its customers. Application s.t.a. allows you to face everyday work with simplicity and effectiveness. Today we are talking about the software Tremuri. Tremuri is a software specialized in masonry structure analysis. Tremuri performs nonlinear pushover analysis for seismic assessment and retrofitting. Now Tremuri performs analysis according with Eurocode 6, Eurocode 8, Italian National Code, Switzerland National Code, and the Netherlands National Codes, and it's available in Italian, English, German, French, Greek, and Albanian. Tremuri takes origin from the Professor Lagomarsino academic research and actually is used to this purpose in more than 80 universities around the world. Engineers companies that use Tremuri for professional purpose are widespread in more than 30 countries. Now let's go through the modeling inside Tremuri. One of the most important characteristics of Tremuri is that it is possible to model floors with their real stiffness. As you can see in the picture, this allows you to take into account the correct distribution of the seismic forces on the walls. Into Tremuri are available a library of vaults and floors, and in this way you can easily model this kind of elements. These are the vaults that are available into Tremuri. And even if the majority of the floors can be modeled with this library, into Tremuri it's always possible to define directly all the parameters of a floor in order to create your own definition and the real stiffness of the real floor you have in the structure. Moving to the vertical elements, several structural objects can be modeled into Tremuri, like a single masonry wall or reinforced concrete walls, columns and beams, and a combination of walls with beams and tie rods. Into a wall can be modeled different materials, different elements, and then they can also have the function of reinforcing the current wall. To reinforce walls into Tremuri, you can easily also model reinforced masonry, reinforcement with FRP and FRCM, and this will be the focus of the example we are going to see today. The mesh inside Tremuri is specialized for masonry structures and is made with a frame by macro elements method. This method has been studied for the masonry structures to better represent the behavior of a structure made with the main structure in masonry. Using this method, and thanks to the automatic mesh performed by the software, the engineer can easily pass from the reality to the model, taking into account all the significant aspects of the structure. Now we can move to the software and see the examples. Let's open Tremuri and a model already made of a real structure that is made in masonry. This is an existing building near Torino, it's a school, and as you can see it's made with several different elements in masonry and reinforced concrete. We can move through the structure and we can see how it's made. Opening the table of elements. In this table are reported all the elements that are included into the model, and so you can consult it and have an idea of what has been modeled. Into this tab you can consult it, but you can also change the characteristic of the elements one by one, or selecting more than one and changing together. As you can see, there are floors, vaults with the definition, geometrical, and the loads. This model has been already meshed and calculated, and so we can see now the automatic mesh made by Tremuri. Into the mesh we can recognize piers and spandrels, piers that are these kind of elements with their geometry and the material, the spandrel in green, and the reinforced concrete beam that has been modeled. Let's move now through the results of the pushover analysis. This is the result of a seismic assessment. We can open the yellow analysis, that is the worst one in the X direction. And so we can see which is the seismic evaluation of the building. Into the results, there is the pushover curve, obviously, but there is also the view of the walls, in which the colors represent the failure or the damages of the single elements. In this case, we can also open a table in which are reported all the failures into the model, and as you can see in the wall 1 and 3 there is the majority percentage of failures. The red color and the yellow color represent the failures. So, as we have seen, there are problems into the walls 1 and 3, so we can try to perform a retrofitting of these two walls, moving back to the structure tab. So we can select the walls in the level 4, as we are already in the level 4, and go through the edit. Into this view we can see the elements that has been modeled, so masonry panel with the existing masonry material, in which there are all represented now all the elements for the calculation, including the shear and for drift and for bending. This is important to know them, because this is the standard for the Eurocodes. Into the second tab we can starting to insert the reinforcement. We have three options: inserting a reinforced masonry as a widespread reinforcement, or a reinforcement made at the end of the panels. What is needed is the area of the single rebar or the area of the widespread reinforcement, the steps, so the distance between the reinforcement and the material. Very similar is the reinforcement applied on one side or on both sides of the masonry panel. Also in this case you need the geometry and the material. But and the third one is the FRP reinforcement, the focus of our presentation today. In this case the table is a little bit different. It represents first of all the characteristic of the masonry on which we would like to apply the FRP, and then the characteristic of the elements that constitute the FRP. To introduce all these values, inside the Muri are available the libraries. In this case, we are already uploaded the library from the constructor Mapei, and you can see here some of the products that are available: FRP and FRCM. All the numbers are already loaded, so we can select one of these products, and automatically the software upload all the characteristics of the FRP that we have selected. Now we have only to insert the dimension and the characteristic of the masonry panel on which we are applying the FRP, and the distance between two stripes of the FRP. This is important because the reinforcement is made by the combination of masonry structures and masonry material, and the FRP we are applying on the wall. So it's the combination of these two parts that creates the reinforcement. At the end we have to give it a name of the reinforcement, so we can recall it for the other parts of our model, and clicking OK, we create our reinforcement. All the characteristics are made there. As you can see here, the drift are changed for bending and for shear, because inserting this kind of reinforcement is not only the characteristic of the FRP that are taken into account, but it's the characteristic of the combination masonry and FRP. So the constitutive law of this element has been changed into a constitutive law of our reinforced masonry, and also the drift for shear and for bending are changed according to Eurocode 8. So we can go back to the description of our wall, and we can select the reinforced one that we have selected here. As you can see, there is the existing masonry in brackets, because the reinforcement one has been defined in relationship to the existing masonry. So this reinforcement can be applied on the existing masonry. If we have another kind of material inside the software, we have to define another reinforcement to apply to the other masonry material. So clicking OK, we are applying the reinforcement. On the other wall, the wall number 3 we have seen before, we can also apply the reinforcement only by clicking, selecting the reinforcement and select from the drop-down menu the reinforcement we have already defined. So we can define it in all the part of the wall, and then we can go back to the calculation. To insert the reinforcement also in the calculation model, the meshed model, we have to go back to the global analysis and select the icon of the mesh, because the mesh has been should be redefined as we have redefined the wall. We can move to a model that has already been meshed and calculated, so we can speed up our presentation. We can open the mesh of the single wall we have reinforced, so we can see now that going with the mouse over the elements, we can see that there is the material and the reinforcement, and we can move through the results. In this case, the new analysis that is the worst is the number 16. We can open it, and we can see now that in the prospect of the wall, the masonry pier are not broken. They are plastic, but not there isn't any failure. Into the results, you can see also all the forces applied on the masonry elements. So in this case, the number 358, 59, 60, and 61, that are the 4 masonry piers that we have reinforced. And so you can see step by step all the forces applied on these elements that are into the model. This kind of results are available for every element, every beam, every tie rod, every columns into the model. Also for the floors, for the equilibrium at the nodes. So we can also have a comparison of the 2 models we have calculated. So we can select the FRP walls that is the previous model, and in this diagram we can see in blue the new model, the reinforced one, and in green the old one. So since the 2 walls were in the X direction, there is an improvement of the performance in this direction, as you can see in the image. This is an easy way to understand how it's been improved, the performance of the wall. Another thing that we can do is the analysis of a single wall. So we can select a single wall and perform a pushover analysis of a single wall. Also in this way, in this case, we can see the performance of a single wall and have a look of which are the elements that are more sensible to the failure. We can select the wall in the plan, and then the software automatically show us the possibility to calculate, selecting the best control node. Once we have calculated it, we can open the results of the pushover analysis of the single wall, and also in this case the worst analysis is the yellow one, and we can see here in the prospect the results of the single wall. As you can see, our masonry piers are not failed. Also in this case, there are failures in other part because the pushover analysis is a collapse analysis, so we have to find something that is failed at the end. Now we can move to the local mechanism analysis. So it's another local analysis as it was the single wall pushover analysis. In this case, we can analyze the out-of-plane behavior of our structure as a rigid body. So we can select the wall, giving a name of the mechanism we want to analyze, and then we can design or drawing on the wall the profile of the rigid body that have to overturn on our structures. So we can run the calculation, select the quote constraint, the retraction of the hinges, and the reduction for the coefficient factor. At the end of the calculation, we can see the factor for the seismic assessment that is not verified. It's 0.55. And so we can go through a sort of reinforcement, inserting the effect of a reinforcement on the wall. So we are inserting 2 forces that represent the effect of a reinforcement to prevent the overturning of this rigid body. we can insert the coordinates related to the nodes already present into the wall, and the force that we would like to test if this force is enough to verify the mechanism. We can see here in green the two forces inserted with their placement, and so we can run again the calculation, selecting the same option or before, and in this case, in the results, the seismic acceptance is verified because we have a value of 1.15. So now what we have to verify is that if the forces that we have inserted before, so we can go back to the forces, can be supported by the reinforcement, so they must be verified from the table of the manufacturer of the reinforcement we want to insert. Okay, so for this example we have ended, we can move to another model in which we can see another kind of reinforcement. In this case, this model is a public building, and it's important the entrance of so the facade of the building. As you can see, there are a lot of columns in this case. So we can go through and see which are the problems of the seismic assessment of this building. We can move first of all to the structure to see the definition, for example, of a vault. These are the parameters of the orthotropic membrane that has been calculated automatically by the software, and that represent the stiffness in plane of this vault. In this building there are a lot of vaults, so I would like to show you one of them. Going through the global analysis, we can see the results of the global analysis for this building, and moving through the facade where there are all the columns, it's clear that we have some problems with these elements because there are a lot of compression failure for the columns in this facade. So you can see the violet color for these elements. So we can close the results, go back to the structure tab, and insert a reinforcement for this element. So we can start from the first one, go through the edit, as we have seen before for the masonry panel. Also in this case we can select the reinforcement. The tab is a little bit different from the masonry panel because these are columns, so the parameters are different. In this case we can select an FRCM reinforcement, going through the library and selecting the material from the Mapei library. So this is an FRCM that will be applied on the columns. Clicking OK. Also in this case we have to select the exposure of the reinforcement, the total thickness, and the compressive strength, and then we have to insert a name to recognize it if we have made more than one reinforcement. By clicking OK, we can see all the parameters, and applying the reinforcement to the column, we can see that in this case there is a reinforcement improvement factor that allows you to know the percentage of the improvement of the performance of this column. By using the copy and paste command, we can copy the characteristic of this first column and apply them to all the other columns at once. Also in this case we have to go back to the global analysis and run the mesh again to apply these changes, but we can open the same model with the mesh already done, opening the prospect of the page on the wall. We can see that in the columns as are applied the reinforcement, and so we can move through the results of the pushover analysis for this building. We can open the worst analysis in the X direction, that is number 12, and in this case, showing the results for the facade, the columns are not failed. We can open the results relative to the single columns, so we can see especially the normal forces on every column, and moving through the various steps of the calculation, we can see the changes of all the forces applied on the columns, as we have seen before, into the for the walls and for the masonry piers. What we can see now is the results of another kind of reinforcement that is available in Tremuri, that is the reinforcement with a steel or wood frame. So reinforcement with a frame. We can open. It can be applied on floors, vaults, and walls. We can open here the application on a vault. So we can insert the profile of the axis of the reinforcement we want to apply on these vaults, and then we can select if there is if it is a beam or a tie rod, inserting the characteristics of these elements and the material that constitute the element. In this case, we have inserted a reinforcement on a vault. We can see the reinforcement inserted in yellow in the plan, so we can recognize the elements that has been reinforced in this way. And the same thing can be done also on a wall. So we can open a wall for the edit and insert stiffening frames. Also in this case, you can upload a DXF file, because maybe you have already decided the shape of the frame reinforcement. And then we can start to join it directly on the wall using the command we have used before for the stiffening of the walls. Once we have defined the geometry of the reinforcement, we can insert the definition of all the elements, clicking on them, and then selecting the profile from the library or the steel profiles that are available into Tremuri. Also, in this case, once we have defined the reinforcement, we can show into the plan in yellow the part of the masonry wall that has been reinforced. This is another option for reinforcement into Tremuri that is very effective when we have to insert reinforcement into a larger part of the building. Then we can go back to the previous model and see which are the outputs of Tremuri. First of all, the automatic report for the global verification. I moved to this model because we made more analysis in these cases. So we have the pushover analysis, the pushover of the single wall, the pushover and the local mechanism, and a list of automatic images that has been taken by the software from the model. Clicking on the bottom, we can create automatically the report that has been created in a RTF format, so it can be modified as we want. Into the software, into the report, there is at the beginning a short description of the model with the plan of the various levels, including the roof, and then there are the view or 3D view of the building. These are all automatic, taken by the software. Then we can move through the materials with the description of the material and all the characteristics of the material used inside the model, including the reinforcement we have inserted with FRP. Then we move to the geometry. So wall by wall, level by level are described all the elements with the geometry, the materials inserted. So we can move through the level 4 to see the elements that has been reinforced. So this is an existing masonry with the reinforcement 1 for the elements number 397 and so on. Then after the geometry, there is the equivalent frame. So all the elements that has been meshed. So masonry pier, nodes, floors, everything that has been meshed now is reported into the report with the geometry, the material, and all the characteristics. After this, there are all the loads on the floor, the loads applied singularly, the spectrum, the pushover analysis with a short description, theoretical short description, the analysis that we have performed, and the results of all the 24 analyses that have been calculated. Then are reported the two worst analyses, one for the y direction, one of the x direction, with the plan deformed and the prospect of the wall that has the majority of the failures. And at the end, there are also obviously the pushover curve of these two analyses. This then there is the result of the single wall pushover and the local mechanism with the short theoretical description and with the results of the kinematic analysis. This is the report. There are also other outputs from Tremuri, because we can move through the export tab and see that it's also possible to export all the results for pushover and static analysis. In this case, we can select the pushover analysis. We can select the numbers for nodes, walls, or any other elements that has been inserted. In this case, there is an export to an Excel files in which we can find all the numbers calculated during the pushover. So for every step of the calculation, for every wall, for every single element, there are the normal forces, the shear, the momentum calculated, and also the displacement, the drift. So for example, here for analysis, starting from there is all the results for analysis for wall number 1 and the step number 1. So all the results that are taken from Tremuri can be exported to Excel, so the engineer can have the complete control of all the numbers that has been calculated by the software. My presentation is ended, so I would like to thank you everybody for your attention. As you can see here, there is my email and the email of our distributor e-disti, so you can send us your question about the software and everything you can are interested about the Masonry analysis for Seismic. Thank you everybody again, and see you on the next webinar.